everybody, welcome back to Algebra 3. Today we're going to continue our work with angles and actually work with some triangles today. So today we're going to do a Pythagorean theorem review and we're going to do some right triangle trigonometry. So Pythagorean theorem, we will review that formula and work with it, and then right triangle trig, we'll talk about sine, cosine, tangent, and also 3 more trig functions. So first of all, let's talk about the Pythagorean theorem. I've got a bunch of problems here where we have to find the missing side. Notice that all of these triangles are right triangles, and I can tell that they're right triangles because they're marked with a right angle. That's good because the Pythagorean theorem only works for right triangles. Okay? And it only works for right triangles. The formula for the Pythagorean theorem is a squared plus b squared equals c squared, where a is a leg, b is a leg, and c is the hypotenuse. So basically c is the hypotenuse, and the other two are legs. So the hypotenuse you can always find by looking at the right angle, and it's straight across from it every single time. So this is the hypotenuse, this is the hypotenuse, this is the hypotenuse. The other two sides are a and b, and it really doesn't matter which side is a and which side is b. So let's look at this one that's labeled number 9 and let's try it out. Let's say I wanted to find this missing side. It happens to be the hypotenuse. So I could do 7 squared plus 10 squared equals the hypotenuse squared. 7 squared is 49. 10 squared is 100. 149 equals h squared. So to find h, I could take the square root of both sides. H would be the square root of 149. And if I take that decimal, which I think Delta Math asks you to do, h is approximately 12.207. If you have a right triangle like this where you're given the hypotenuse and a leg and you have to find the other leg, just be careful, watch which information that you are given. So let's call this side A, this one B, because C is always the hypotenuse. So I would set up the equation a squared plus b squared equals c squared, or I would do 15 squared plus b squared equals c squared, but c squared is 25 squared. So then I would square 15. 15 squared is 225 plus b squared equals 25 squared is 625. If I subtract 225 on both sides, I get 400. Take the square root of both sides, and b is 20. So side B, 20. You'll also have some word problems involving the Pythagorean theorem. My advice is to draw a triangle. It says one of the legs of a right triangle. Oh, right triangle. So I'm going to draw a right triangle. So one leg. So it tells me it's a leg. That means it's not the hypotenuse. So one leg is 6. The other leg, not the hypotenuse, is 16. Find the measure of the hypotenuse. So I'll label that C. So then I would set it up. I would set 6 squared plus 16 squared equals c squared, and then I would solve and find out what c is. So if you've got the word problems, just make sure you read them, draw a picture, and label. Another one, we have a certain television is advertised as a 29-inch diagonal. So let me draw. Well, that doesn't really look like a TV, does it? Anymore, at least. Okay, so that looks more like a TV. Certain television is advertised a diagonal of 29 inches. So diagonal means that it goes from one corner to the left. The diagonal length doesn't say which way, so okay. So let's say that's 29. TVs have right angles. If the width of the TV is 20, how many inches tall? So I would solve for this. So I could set up 20 squared plus x squared equals 29 squared, and then I would solve the problem. All right, now let's talk about some trig. Okay, so trig functions. In the past, in your geometry class, you were introduced to sine, cosine, and tangent. Sine, cosine, and tangent are a ratio of two sides of a right triangle. So again, this only works for right triangles. Your teacher may have given you this acronym, but if they didn't, you should memorize it. So, ka, toa, because it helps me memorize the ratios. Sine is the opposite over the hypotenuse, or the so. Cosine, the ka part, is the adjacent side divided by the hypotenuse, and tangent, the toa, is opposite divided by adjacent. Now, what does that all mean? Depends on which angle you're talking about. So one of the acute angles will be labeled. This one has been labeled, we call it theta. That's what that symbol means. And it tells you which angle to look from. So looking from this angle, I need to find the opposite side. So opposite from this angle, 8 would be the opposite side for this triangle. Adjacent means touching. So this angle is touching 6 and 10, but 10 is always the hypotenuse. Hypotenuse is always hypotenuse, which means 6 is the adjacent side. So if I go to find these ratios, I would say that the sine of theta is, so from theta, the opposite side, 8, over the hypotenuse, 10. 8 over 10, 4/10. Cosine of theta, the adjacent side, 6, over the hypotenuse, 10, 3/5. Tangent of theta, the opposite side over the adjacent side, opposite 8 over adjacent 6, and that reduces to 4/3. So here's a couple different examples. Let's pick, whoops, didn't mean to do that. Let's pick this one. Okay, so I have a triangle. Let's say I wanted to know the sine of A, the cosine of A, and the tangent of A. Well, since I say A, that means I'm looking from angle A. So from angle A, first of all, 2 is the hypotenuse because it's across from the right angle. But from angle A, the opposite side is 1, and the adjacent side is the square root of 3. So the sine of A, that's the so part, opposite over hypotenuse. Sine of A is opposite 1 over hypotenuse 2, so 1 over 2. Cosine, adjacent over hypotenuse, square root of 3 over 2. Tangent, opposite over adjacent, that's the toa part. Cosine is ka, toa. Opposite over adjacent, 1 over the square root of 3. Now, when you go to enter this in Delta Math, I think they're going to make you rationalize the denominator. It means you can't leave a radical in the denominator. So multiply the top and the bottom by the square root of 3. 1 times square root of 3 is square root of 3. Square root of 3 times square root of 3 is just 3. So leave it like that. Now there's also, in addition to sine, cosine, and tangent, there are 3 additional trig functions. Their names are cosecant, secant, and cotangent, and their abbreviations are CSC, SEC, and COT. And here's how they work. If sine is the opposite divided by the hypotenuse, cosecant is the reciprocal of that. So the reciprocal means flip the fraction. Cosecant would be the hypotenuse divided by the opposite. So let's say I have this triangle here. Let me just make one up. 3, 4, 5. And I put theta here. The sine of theta, let's label our sides from theta, this is opposite. Hypotenuse is 5, and that makes 3 adjacent. So the sine of theta, sine is opposite over the hypotenuse. Let's delete that. Opposite over hypotenuse, so sine would be 4 over 5. The cosecant is the reciprocal. So instead of 4 over 5, it would be 5 over 4. Let's talk about cosine. We know cosine to be the adjacent side divided by the hypotenuse. Secant is the hypotenuse divided by the adjacent side. So if the cosine of theta for this triangle, adjacent is 3, hypotenuse is 5, then the secant, you flip that, 5 over 3. And then for tangent, we know tangent is the opposite over the adjacent side. Cotangent is its reciprocal. It's the adjacent side divided by the opposite. So for this, the tangent would be opposite 4 over adjacent 3. Cotangent is the reciprocal, 3/4. So it's like getting 3 new trig functions, but it's also very familiar because they're just the reciprocals of the other. So then you'll have a couple of delta math problems where you have to solve, but you can use Pythagorean theorem to find the third side and then find all of them. And I believe that's all. So this should be enough to help you, I believe.